In this video and in the next several videos, we are going to look at problems involving related rates. So in this video, we're going to talk about related rates and the strategy to solving those in general. And then in our subsequent videos, we will have lots of examples. Each related rate problem is slightly different. So it is important, it is valuable for you to understand how to solve related rates problems in general. What is the strategy? What's that methodology? Without getting too focused in on the details of any one problem. So you want to have a broad strategy, but let's talk about what are related rates problems. So if we let t represent time, then the rate of change of a quantity x is dx dt. It is the derivative of x with respect to t. Right? It is the change in quantity x with respect in relationship to time per unit of time. We will use implicit differentiation to find rates of change. And so implicit differentiation is going to show up of two or more related variables. So we're going to have some variables that are related. They're both changing with respect to time. And so if we are given an equation with quantities that are changing with respect to time, we can implicitly differentiate both sides of the equation, treating each variable as a function of time. And so let's implicitly differentiate the formula a equals pi r squared with respect to t. So we are implicitly understanding area is a function of time. So this is a function of time. We are also understanding this is the radius is also a function of time. And so both of these are functions of time. So when we take our derivative, we're going to pick up dA dt. We will also pick up dr dt. So on that left-hand side, the derivative of that side is dA dt. The right-hand side, our derivative is pi. The derivative of r squared is 2r, but we are going to pick up a dr dt. So the rate of change in the area is 2 pi times the current radius times the rate at which that radius is changing. That is our implicit derivative. Good. And that's really what we are going to look at on each one of our problems. We're going to come up with that derivative, and then we're going to make some observations. So how do we solve a related rates problem? What's our strategy? Well, to solve a related rates problem, first, if it's possible, if it's appropriate, make a simple sketch. So you're just going to draw a picture that represents the setting so you can start to think about what is being represented there. Then you want to, in that sketch, you might go ahead and define your variables. So what values are changing? What values are constant? Then you want to set up an equation relating all of the relevant quantities. At this point, only plug in quantities that are not changing throughout the situation. When we solve these problems, we're going to often be interested in what is occurring at specific points in time, where those points in time are defined by a quantity, right? So on that previous problem, we might say we want to know at what rate is the area changing when the radius happens to be 3. Now that radius is not fixed, and so I'm not going to plug in that value of 3 prior to taking the derivative. That radius is changing. So at the back end, later on, we're going to plug in those values, but not the only values we plug in initially are those that are not changing throughout the situation. Then we'll implicitly differentiate both sides of the equation with respect to time. Right? So that's important, with respect to time. And then we can substitute in the values for the known quantities and derivatives and solve for that rate that we are looking for. And that's what it looks like. That is our process of solving for related rates. So we will have videos where we work through several different examples. So we will catch you in some of those example videos. We'll see you there.